Hi everybody, today we're going to introduce fixed income derivatives. So introduction to pricing fixed income derivatives. Okay, so what is a fixed income security? Let me give you an example. So here we have our t equals 0, we buy a bond at t equals t, it matures and gives us $100 or let's say K dollars. Okay, so this is a fixed income security because the amount that we get at time equals t is fixed, $100. Okay, so now we want to price a derivative on this, and we want to price this thing in general. And it turns out this is more complicated than pricing derivatives on underlying stock because the price of this is dependent on interest rates that vary over time. So let me draw you something called a yield curve. So this is a yield curve for t equals 0, and it looks something like this, hopefully. Okay, so the yield curve is the lending or borrowing rate for many times in the future. So here is t on the bottom. So if we borrow for, let's say 2 periods, it's here. But if you borrow for 4 periods, then the interest rate is this one. So here's the S of t, which is the interest rate for different borrowing and lending periods, and this is all assuming that we're currently at t equals 0. So at t equals 1, we're going to have a totally different yield curve, and so in order to price these fixed income derivatives correctly, we need to have a knowledge of this yield curve for infinite number of times in the future. So this is different from the just modeling one underlying stock, which is just a scalar value instead of this whole curve, right? So apparently then pricing these fixed income derivatives is sort of more complicated. For many of these models, instead, we're going to focus on something called the short rate. Okay, so the short rate, RT, is going to be the instant interest rate between t and t plus 1. So here we have a short rate. So here we're at t equals 0. We have a short rate RT that holds between these. And at t equals 1, we have a new short rate RT plus, R1, R0, and R1. Okay, so then what we're going to do is we're going to model this short rate using the binomial model, just like we did with the underlying stock in the previous course. So here we have R0. We know what that is because we're at time 0. Okay, and now the short rate can either go up. So this will be, R0. R00, okay? It can either go up to R11, or down to R10. So this notation is R and then the time and then its position on this is called the lattice. So here it's going up, this. So again, this is binomial, and it keeps on going up. Like this, okay? So our interest rate or our short rate, we're assuming that it sort of follows this binomial model. And so here, let's take a look at how we would price a zero coupon bond, okay, or any sort of fixed income derivative. So like I said, the fixed income derivative price depends on the interest rate. So we're assuming, depending on the short rate, right, it has a different value. So here we have an initial price, we don't know what this is yet, of the zero coupon bond. I'm going to say Z00, okay? And then it's going up. We don't know if it went up, but 011 to a new price. So this is assuming the interest rate. So the interest rate at this point is R11, right? So the interest rate has gone up or down, and now we end up with a different value because the price of the zero coupon bond is dependent on these interest rates, right? Z01 and so on. Okay. So as we noted before, so here I'm going to draw out an example. As we noted before, the price of this zero coupon bond at time equals t, or the maturity, is what it pays out, $100. So here, the payout or the price of the zero coupon bond is always $100 at the end, right? So knowing that, it's actually fairly easy to find out what the price of the zero coupon bond is here. Z0, Z22. So if we know that in one period we're going to get a guaranteed $100, and we know that the interest rate here is R22, because the short rate, the thing about the short rate is we don't know what it is in the future, except the moment, like when we suddenly step into time equal 2, now we know what the short rate is, what the instant sort of borrowing and lending rate is, right? Before we don't know. So if we're here, we know what R22 is, right? And what is the price Z22 of this bond that we know 100% in one time period is going to give us $100? Well, it's going to be just the $100 discounted, right? So 1 plus R22 times $100. Okay. So now, what about right here? Z221. So the price of this will be 1 plus R21 times 100. Okay. And according to our model, right, R21 is going to be basically, we modeled again the short rate by this binomial model. So R21 is going to be lower than R22, which means this actually, the price of this, assuming we're right here, is actually going to be higher. So Z21 is actually bigger than this. Z22. So let me give you some example numbers. This could be $85, okay? And this could be 90, and this one could be 95, okay? So the lower the interest rate, the higher the price of your bond is, okay? So this was fairly easy to price because we know 100% that the payout next period is $100. It's sort of more difficult to price this right here, and this because the payouts one period in the future are now they're not both $100, now they're different. And so we're going to use the same strategy that we used before with pricing options on underlying stock. We're going to use the risk neutral probability, right? So for example, ZTT, right, is equal to, so it's going to be 1 or, yeah, I'll just say ZT, okay? Assuming we know exactly on the space we're at. ZT is equal to 1 plus RT, okay, multiplied by the expected value, according to the risk neutral probability, okay, of ZT plus 1, okay? So what does this mean? So according to risk neutral probability, which exists according to the fundamental theorem of asset pricing, so this risk neutral probability exists, right? We're going to discount it, and that's going to be the price of our zero coupon bond right here, right? So that's great, except we don't know what Q is. In the past, we were able to derive Q by actually constructing the replicating portfolio. Here, honestly, this might come as a disappointment, but we're just not going to even bother to do that. We're not going to find out what Q is. Instead, this is the apparent philosophy. Let me just write down philosophy of fixed income securities. Or derivatives, okay? Instead, we're just going to look at the bond, at the price of the bond, and then figure out Q. So we're apparently, so I was trying to come up with a good way of, like, creating a replicating portfolio. The answers that it was trying to give me was you could construct a replicating portfolio by maybe buying some bonds that were shorter maturity and some that were longer maturity, and then based off of that, you could get a payout of either 85 to 90, depending on where the interest rate goes. But I never was able to figure this out. So apparently we're just not even going to try. We're just going to assume it exists. And even more unsatisfying is for these like sort of learning examples, we're just going to assume that Q equals 0.5. I think this is right. It's just totally confusing to me. Why we do this? I don't think in practice, I don't think Q equals 0.5. These risk neutral probabilities aren't 0.5, but okay, we're just going to assume that they are, okay? So, like I said, the ZT, right, is equal to the, it's just the expected value according to the risk neutral probabilities of ZT plus 1 discounted by 1 plus RT, okay? So now there's a nice formula that we're going to develop. So this BT this will be the price of the cash account, okay? And the price of the cash account goes up because interest rates go up, right? So BT is equal to 1 plus R0 multiplied by 1 plus R1 plus dot 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 all the way to 1 plus R to the T minus 1. So this is going to represent our cost of borrowing or lending, or this is going to be a cash account, right? We can put money in there and it'll grow next period, right? So notice that BT plus 1 over BT is just equal to 1 plus RT. Okay, so I'm going to substitute this back into the original equation and just end up with, oh yeah, and I should also note that this BT is not known, right, until you're at time T. That's why this is not like a risk-free cash account. It could be, not very good, this cash account, depending on where the interest rates have gone, right? So this is not like something you 100% know is going to be a good thing. So anyway, so we're substituting it in there. We get ZT is equal to BT over BT plus 1. And then, as usual, the expected value according to risk neutral probabilities of ZT plus 1. Okay. So then we're just going to move this inside. We're going to move this back. And we end up with ZT over BT is expected value according to risk neutral probabilities of ZT plus 1 over BT plus 1. And I think based off of this information, we can conclude that ZT over BT is a martingale. I don't think this was said in the lecture, but I will just say it. Okay. So again, what have we done? We have developed a model for the short rate. Based off of it, we have developed a model for the zero coupon bond. We haven't even bothered to construct a replicating portfolio. We're just going to assume that Q exists. And for pedagogical reasons, we're going to assume it's equal to 0.5. And finally, we've constructed this nice sort of thing here. And I think there was also a part on what if it's not just a zero coupon bond? What if it actually is a coupon paying bond? What does that mean? That means that we're getting, so the ZT plus 1 instead is ZT plus 1 plus a coupon, CT plus 1, which does depend on the, it depends on the time period, right? Or no, I think it's just C probably. It might be just C. Okay, not sure. Yeah, but the point is that then this goes into, if we want to make it a coupon paying, then it goes, you can see the C back in the original equation. Okay, but it's not super interesting. So hopefully that makes sense. So yeah, if we keep following this process, right, recursively, then we can end up with a price here for Z00. I think next time we look at the price of an option on this zero coupon bond, which is sort of interesting because, like, let's just say your strike price is like 95, or like, yeah, what if it's like a put? I mean, okay, so the price of your zero coupon bond is never going to go above 100, right? So let's just say your strike price is like, I don't know, literally anything, right? I think only puts. Okay. Anyway, I guess we'll have to wait for next time. Okay. Thanks.